Okay, so first I'm going to have you put your hand over something, and you can tell me, you can describe to us what it feels like. So put your hand right over this. Can you feel anything at all?
Heat.
It's warm? Okay. All right, thank you. Put your hand back down. Okay, now, I'm come over here. Lost it. There it is. Okay. And you're going to put your hand over this and tell us what you feel. Don't touch down. What do you feel?
Nothing.
Nothing at all?
Nothing.
The temperature did not change at all.
It's cold.
Okay.
Wait, is
It's
it?
cold. Now feel this one over here.
It's warm.
Okay.
Very warm.
Now feel this one again.
That one's cold.
Okay.
That one's cold. I can tell.
All right, good. All right. And can you feel a difference taking your hand over here?
Yeah.
Okay, good. So what you're telling me is the air above this is you can feel
Different temperature.
different temperatures just from the difference in the temperature of the water. Okay. Okay. So what we're going to do now is we're going to take these two pieces of ice and put them into these two containers. And the rules are you want to get yours to mix or melt as quickly as possible, but you do not want to put your hands in or any other object in the water. Okay, so you want to try and mix it. So let's see who can do that first. You can move it. You can think of other ways you might want to mix it, but you cannot put your hands or another object in. Okay, are you ready? And go. Whoa. You're right? Okay. So, Jacob, the only thing you might want to do is put
Tip it
yours,
over.
I guess yours is an iceberg. Okay, that's fine. All right, so see if you can, now what's the other thing you might do without shaking it if you wanted to get it to melt? Is there any other idea you might have?
Can you blow heat on it?
Oh, good idea. So you might want to blow on it, so you could try that too.
Okay.
Wow, that's some great big blows there. That's exciting.
I know.
Mine's rolling.
Okay, so what's happening? It's melting, it's melting. But what else? Anything? Is it changing color? What's it changing to?
Purple.
Great Kool-Aid.
It's kind of a purple color, yes.
Faster.
It is kind of a purple color.
Purple drink.
Thank you, my lovely assistant. Okay. So what else? You can shake it, okay, and it kind of, that would melt it faster, and then you would blow on it. That might be another way. Okay. All right.
Okay, why is his melting faster?
I don't know. I guess he's got some melting skills.
Because I'm hot.
Oh, that's it? Now we know.
Why is mine melting?
Did you ask it nicely? You have to ask
This
it.
is a deeper purple now.
Yeah? Is this going to be a deeper purple?
Yes.
Turning into a
Because it's
blue.
melting
A
faster.
blue.
Cheat away, put in more food coloring.
Maybe so. Okay, but it's not even the color that we want. It's more that we want to try to get it to melt. So, or to move around. Okay? Okay, what is it making in the water when you're moving it like that?
Cold.
Currents.
Currents. It's making waves, right? So moving it around makes waves. Do you think if it was just sitting perfectly still? We've had a tidal wave, a tsunami has hit the left bucket. So, what do you think would happen? Oh, yours is melting. Look at that. It's beautiful.
Well, if it was staying still, I don't think it would melt because, like, don't you need, like, the energy or whatever to move it? I don't know.
It might take
It has
a
to
lot
push
longer.
over and melt it.
It would eventually probably,
Yeah,
because
please.
think about your think about like a drink. If you set your drink down somewhere and you forget about it and you come back, you know, even if your soda was cold or your
I
water
hate
was
that
cold,
stuff. I hate when that
the
happens.
ice will eventually melt on its own. But
If you're
But it
drinking
takes
though,
longer,
doesn't
right?
It kind of melt faster. 'Cause you're moving?
yeah, that's true. It does. When you're moving it around, it does melt faster. So, good observation.
See, face, the nose, and his eyes. Somewhere.
So that's ice with character. It's interesting because Chloe's is melting kind of bumpy, you know, and Jacob's is kind of smooth.
Just like me.
Yeah, so you're smooth and hot is what you're trying to tell us, right, Jacob?
Mhm.
Okay.
Nope. It's a lie.
Jealous.
I'm jealous. And the girls are saying they're not so sure about that. Okay.
Jacob got no curves.
I've got curves. See, I've got
At
curves.
least I don't have bumps.
Okay.
Bumps. Excuse
In
me.
your ice. Your ice has bumps. Okay. Okay, so our ice is almost melted. This one's still moving around and it's twirling. The ice chunk is twirling in the water.
over there. Didn't move anywhere.
That one's just staying still. I wonder what the difference is.
This one
It's all
looks like
knocked up
there's
against the edge of it. Okay.
And since it's not moving, it's not melting.
No, it's not.
This one's
That's
almost
true.
melted.
So this one's moving around and it's melting quicker. Very good. Okay, so as we talked about earlier, the sun is shining right on the equator, just like this flashlight is, right? And this is daytime on the equator, which is right by the Philippines and right across Africa. It would go all the way around, of course, in 24 hours. So where do you think the water is going to be the warmest?
the equator.
It'll be the warmest in the equator. And how about up here? Is it going to be warm at the top or at the bottom of the Earth?
Not really.
Not really, not on its own, right? So you saw with this that it melted quickly when we moved it, when we blew on the ice or on the water to help it melt, right? So this, do you think if the sun was shining on this area in the middle that it would be hard to live there with the water that warm? Would it be hard for sea life? Would it be hard for people to live there? If it might be hard, right? Because we know that by holding your hand over the water, we saw that the water, the heat, what does it do from the heat and the cold? What do they do from? They rise. So it also affects the air, doesn't it? So it might be too hot to live there on the equator, not just the water, but also the heat that the water gives off. Because how much of the Earth is covered with water? 70 or 71%. Good, very good. So, so this water has to move somewhat, and then the cold water from up above and on the bottom, because this has more snow and more, right? Then of course the equator probably doesn't see snow for the most part, but the top and the bottom do. So, do you think that water might move and mix when the warm water comes in? It does. Right, so it does. So, and have you noticed something about all of the oceans? All of the oceans are, what, are there any separations in the ocean?
Not really.
No, so the water really can travel over the whole Earth through the oceans. And that's how we get heat up here, where it's warm enough to actually exist in Mongolia and even in Canada, the northern United States. If the water didn't move, if it didn't travel, we wouldn't be able to exist there or live there. But the water moves and it carries heat, right, to the colder places, and then of course it does the opposite as well, and it moves the other direction. So it not only warms the water, but it also warms the, what? Besides the water, what else does it warm?
The air.
The air. It does, and it really warms the whole planet. So very good. Okay.